the words GCF before, and you've done it before, but the method that we're using now is slightly different. It's actually a lot easier than what you're used to. Tell me what you know about GCF. What you know, Dylan?
It stands for greatest common factor.
Greatest common factor. What does greatest mean? Most, biggest, right? What is something in common? If me and Antoine have something in common, what does that mean?
Alike.
Alike, the same. Factor, which is a vocabulary word from last unit and that carries over to this unit, is the numbers that multiply together to give you a product. So GCF, greatest common factor, is the biggest same numbers when multiplying. Okay? You did this back in 4th grade and in 5th grade, and you made these lists, these factor lists. And so that's what they have us doing first. So I'm going to show you the old-fashioned way, and then I'm going to show you the new way. Your parents probably don't know how to do the new way. And then if they see it, they'll probably freak out, but I promise you it's so much easier. I use the new way now when I do this because it's so much easier. So I'm going to show you the old way. When y'all see the old way, you're going to go, oh, yeah, I remember how to do that. Then I'm going to show you the new way, and you're going to go, oh, I like that one better.
So it just changed this year?
No, we've been doing it for several years now, but by the time your parents went through school, it's been, yeah. So the first part is, first method y'all are used to are the listing method of the factors, okay? Listing all the numbers that multiply together to give you that particular number. Here we're going to be doing factors of 64, okay? When we do factor lists, you always, and remember if I write it, you write it, always start with 1 and itself. Those are like the bookends. So like, you know on a bookshelf how you have the two separate ends that keep the books from falling over on each other? Y'all know that what I'm talking about when I say bookends? Mm-hmm. Okay, sometimes they come in cute little shapes and things like that, or sometimes they're just little metal pegs and they keep the books from falling over. Well, 1 times anything is itself. It's that number. So that's why we start with 1 on one side and the number on the other, because 1 times itself. So here we're talking about 1 times 64 equals 64. So those are like the bookends. Every other number has to fall in between those two numbers. Okay, excuse me. So then we try the next number, 2. Can 2 go into 64 and be a whole number?
32.
If you don't know, you can put in your calculator, 64 divided by 2.
32.
And you get 32. So 32 works. So I would put 2 times 32 equals 64. Then I would try 3. 64 divided by 3. Do you get a whole number? What do you get? You get a number in a decimal, right? So that's not going to work. So 3 won't work, so then I move to 4. So 4 times what equals 64? 16. So 4 times 16. Will 5 work?
No, isn't it like,
what do you have to have?
An even number and that's an odd number?
No, it doesn't always work that way. Sometimes it does. But 5 does have a special rule. Does anybody know the special rule for 5?
It can only be divided by 0 in itself.
It has to have a 5 or a 0 at the end. And because we don't have a 5 or a 0, 5 isn't going to work. So then I try 6. Doesn't work. 7.
No. 8 times 8.
8 and 8 work. Now, is there any number in between 8?
No.
In between 8?
No.
No.
Between 8 and 8? No. Notice that we get smaller, like we're coming in. Okay? There's no other number between 8, so that means we're done. These are all the factors of 64. Those are the only whole numbers that multiply together to give you 64.
All of them.
When we find GCF, we're comparing two different numbers and we're trying to see which ones they have in common. So here, our question says, find the GCF of 40 and 64. So we're comparing two numbers and trying to find the one they have in common. So 40, you always start with what?
1.
1 and
40.
itself, 40. So those are your bookends, 1 and 40. Then you try 2. Is it even?
Yes.
Yes, so 2 should work.
2 times 20.
2 times 20. So 2,
3 doesn't work.
20. Does 3 go into 40?
No, but
No.
4
Does
does.
4?
Yes.
Yes.
How many times?
10.
10 times.
5 does.
5 and
8. And it's 8.
8. Does 6?
Oh, wait. I've been doing this
Does 6 go into 40?
No.
7?
No.
Alright, and then we're back at 8. So those are the only numbers that'll go into 40. And so then 64, we've already done 64. So you can just copy that list back down.
Is this a new way?
This is still the old way. I've done this before.
It sucks.
Alright, so then you can go back and you can circle everything they have in common. Do they both have 1?
Yes.
Do they both have 2?
Yes.
Do they both have 4?
Yes.
Do they both have 5?
No.
Do they both have 8?
Yes.
Do they have anything else?
No.
What's the biggest number they have in common?
8.
8.
That's your GCF. That's what it's asking for.
That's bad.
That's a lot.
Alright, this takes a second.
A minute.
What I'm about to show you, it takes a second to learn how to get used to it, but the more you do it, it gets faster and it's a lot easier, and it's called the slide method. With the slide method, the goal is the same, but it looks different. And we use what I call the sliding 6. It's 2, 3, 5, 7, 11, 13. Those numbers are very important. Those are the first 6 prime numbers, meaning that there's nothing else can go into those numbers except for 1 and itself. These numbers are useful when you can't come up with any other numbers in your head. You're going to try these numbers. And if none of these numbers work, that means you're done. Okay? All right, same scenario. We've got 40 and 64. We're going to write 40 and 64. Then we're going to draw an L. It kind of looks like an upside down division sign. It's our slide. We'll draw a slide around it. We're going to look at the numbers at the same time. And we're going to think to ourselves, what number do both of these numbers have in common? What factors do both numbers have in common? What can they both be divided by?
2.
2, okay. So whatever we want to use, we can put it right here. Then we're going to divide it out. 40 divided by 2, 20, so your answer goes up underneath it. 64 divided by 2,
32.
32. Whatever number you put out here has to work for both numbers inside the slide. Okay? If it works for one but not the other, you can't use it. It's got to work for both. Okay? So now we've got 40 and 32. I mean, not 40, 20. 20 and 32. We keep going until there's nothing else that can come out of them. Is there anything that can come out of 20 and 32? Think about your multiplication facts. What's something that can come out of both of them?
2.
Use 2 again. Is there a bigger number?
16 and 10. 4.
It's got to be the same number for one, for both of them.
Wait, no,
All right, so if you try 5, 5 will go into 20, right?
And it doesn't have a
Will
zero.
5 go into
No, it
32?
doesn't have a 0 or 5.
5 won't work. 4. I heard somebody say 4. So you're going to draw another slide up under it. And you're going to try 4.
Yeah, it can go in
20 divided by 4.
is 5 and then 8.
That's 8.
And that's 8.
Oh, this is good.
Okay? Now,
Nothing can go to it.
all right, listen. The 5 is in our list up here, right?
Right.
If we get a number down bottom that's in our sliding 6, we try that number. If that number works, great. If it doesn't work, we're done. So 5 divided by 5 is 1. But 8 divided by 5, it's a decimal, so does it work? No. So that means we're done. We can't go any lower. They have nothing else in common. We're done. So to find the GCF, you draw a G on the side and multiply the numbers together.
8.
What do you get?
8.
So your GCF equals 8. Now, you can check your work. 40 divided by 8 should equal 5. 64 divided by 8 should be, that's how you know you did it right. Your GCF should never be bigger than your smallest number up top.
Wow, that's pretty cool.
Okay?
That is good.
It takes some more practice. We're going to practice it, I promise.
When you're doing
They don't like
when
doing
you're trying to
You've got to learn it.
what does that one to 40 and 64, and we use 2, and like what you're trying to find to go like 20 and 32, do you have to use those numbers? Or is that just for the like the last one?
So for the
It's just, so I don't know if you heard Hitchcock, but listen. She was asking, do you have to stick to this list? You do not have to stick to that list. Like we used 4 right here. 4 is not in my list. This is just like a starting place. If you don't know where to start with one of these numbers. It's also your ending place. You have to ask yourself, will any of these numbers from the sliding 6 work down bottom? If they will, you're not done. If they won't, you're done. Okay? We're going to try it over here.
So wait, I have a question about it. So would we put 1 instead of 2, or would we just put 2?
For what?
Like when we're starting, we put 2 on this side, you know, or it can go in. It can also go into 1, but we didn't put that.
You can have 1, but it's not going to change anything.
Yeah.
I want to do it with you. All right, so you've got 24 and 60. Put your slide. They're both even. So when in doubt and they're both even, try 2. Okay?
Yeah, it works.
24 divided by 2.
Well,
60 divided by 2.
30.
30.
Sorry,
All right, draw it. They're still even. You should never leave 2 even numbers. because there's always something you can take out of two even numbers.
Well, I think I know the next one.
What can we use?
6.
You try 6.
6. It can go
You could
in.
use 3.
6 divided. You could use 3. The thing about the slide is whatever you see, you could use. Okay. Some people see smaller numbers. Some people see bigger numbers. At the end, you're going to end up the same. So 12 divided by 6, 2. 6 divided by 5. 30 divided by 6 is 5. Both of these numbers, 2 and 5, they're both prime. They're in our list up top.
So
that means will 2 go into 5?
No.
Will 5 go into 2?
No.
That means you're done. So you would draw your G, and it's your GCF is 12. You can check your work. 24 divided by 12, your GCF, gives you 2. 60 divided by your GCF should give you 5.
Can we do it the other way and do 24 divided by 2 and get
All right. Some of you could have done we did 2 and you got 12 and you got 30. Somebody saw 3. You get 4 and 10. They're both even, so I can't stop. So I would go again. 2 and 5. You're going to end up with the same numbers at the very end. You just may have to take more steps, or you might do a different order.
3 times 2 is 6.
Multiply everything inside the G. 2 times 3 is 6. 6 times 2 is 12. You get the same answers. Okay? The more you do it, it is fun. I enjoy it. It's fun. All right, so flip over your back of your paper. I'm not going to make you do the listing part right now. Okay, unless you just gung-ho and you want to. Okay, I want us to focus on the slide part. I want to do one more with you, and I want you to practice it on your own. Okay? So you've got the GCF of 66 and 60. So under the slide method, you've got 66 and 60. What are your sliding 6? You're going to want to memorize these. What's your sliding 6? 2,
3, 5, 7, 11, 13.
Okay? None of those numbers should work at the end. So 66 and 60. What can go into 66 and 60?
3.
3. Okay. You can try it.
Is that true? Oh, yeah, 30.
All right. So what's 66 divided by 3?
32.
You have a calculator.
34. No.
You have a calculator.
33. It's 30.
66 divided by 3.
33.
22.
And then the next
And then 60 divided by 3.
20.
All right. They're still even. So can we quit?
No, ma'am.
We could do 2.
You can try 2. 22 divided by 2.
11.
11.
Oh, yeah.
11.
10. They're not even.
All right. Another hint. If they're back to back on the number line,
Where's the GCF?
you're done. So like 10 and 11 are back to back when you count, you're done.
6.
You can't go any lower.
Yeah, it's 6.
So your GCF
It's 6.
is 6.
That's easy.
So what I want y'all to do, make sure you get your slide. All right, you're responsible for trying to work through the rest of these. Okay?
Oh, I did it wrong.